Hello, welcome in my second episode on my tutorial series on STM32 programming. Today, I want to show you how to toggle an LED by a hardware button with using external interrupts. So without further ado, let's go. The procedure is same. Let's select the board. Nucleo 64, F3, PO3, RE. Here you can get the datasheet. Let's go with tutorial external interrupts. Again, C language, executable, STM32 cube. Let's go. Yes, initialize in the default mode. Okay, we are in. Pinout, clear pinouts, yes. Clock configuration, 48 MHz. Okay. Wrong. Let's generate code. Yes. Okay, the procedure will be very similar. At first, I will have to set up the LED. As the same as the previous episode, I'm going to use two LEDs at once. I can actually copy the configuration from the previous project. I've got it opened here. I can copy basically this. In this episode, we will not use delay. Main, over here. Git. Let's make it like this. Let's save. For making the code more readable, I'm going to add some comments. Okay, let's set up our button. At first, we must set up the clock, peripheral clock. It is in the same register as for the previous GPIO port. As you can see, I have my button connected to the port A. So we find GPIO A enable bit. Let's set up the GPIO registers. GPIO A motor. To set up a GPIO as an input, we have to make sure that both setup bits are 0. We can ensure this like that. I will also write the other registers. 0. I have my button already set up as a pull-up on my breadboard, so I don't need to set it up over here inside the microcontroller. So I will keep the pull-up pull-down register in a reset state. Okay, now we must initialize our external interrupt channel. At first I will write a comment over here. And let's go to the reference manual. Over here, we must go inside System Configuration Controller. And over here we can already see feature a set of configuration registers. The main purpose of the System Configuration Controller are the following. And we can see many peripherals. The most important is managing the external interrupt line connection to the GPIOs. This is what we want. So let's find the registers. Here it is, external interrupt configuration register. But as you can see, here, each external interrupt channel has reserved 4 bits. As you can see, we can set each external interrupt channel to independent ports. But the thing is, I'm using pin 5 on port A. So I must go a little bit further. So we can see I will be working with the second configuration register with bit 4567, and at the bottom we can see that port A actually is all zeros. So technically we can keep it as it is, but I want to show you how to set it up. So let's go back into our IDE. EXTI control register, and here we can see, if I will open it as a declaration, yes, that it is an array of 4 elements. It is because over here, actually I can show it over here, that we can see that the external interrupt configuration registers, here is first element, second element, third element, fourth element. You can see it ends with the channel 15. So over here, we see it is an array of 4 elements. So I need to write the second element, which is 1. Because I'm using second configuration register here, 5th channel. So I write 1. At first, I want to make sure that on the pin 7654 is nothing. At first, I must clean it. Okay, like this. Yes. And now I will set it for port A. I can basically copy it. I will just delete this thing. Port A. As you can see, we wrote 0. Save. Okay, so now we have basically set to our microcontroller that the external interrupt channel 5 will be connected to the port A. But to properly enable the external interrupt channel, we have to go further. Interrupts and events. We'll go straight up to registers. Okay, and this is the first register which we have to set. So, interrupt must register. We can see when if we set the value to 1, interrupt request from line X is not masked. This is what we want. And we know that the button is pin A, pin 5. So let's set it up. There are mask register. Five. Position 5 and we are setting 1. So basically, if we unmask this bit in the interrupt mask register, the MCU will not ignore the interrupt requests. Okay, I've done a mistake there. Actually, switch this macro and write there have to be mask register. MR5. I have accidentally chose wrong one. Now it's correct. Okay, let's set up the next register. So this is the next register we need to set. Basically, I want to use falling edge as a trigger for interrupt. This is because I have the button in a pull-up setup. You can see falling trigger event configuration bit of line X, falling trigger enabled for event and interrupt. FT5. Okay, the next step is that we have to set the priority in nested vector interrupt controller, and then we have to enable interrupt requests. I can actually use this and set priority over here. Set it. I will keep it 0. Well, and we have to find the vector number of the interrupt request. For this, we will go to the reference manual, interrupts. Here are the vectors. And I know that I'm using pin 5. Here is channel 1, 0, 1, 2, 3, 4. And here is the vector for channel 5 to channel 9. So let's copy it. And it's interrupt. See, it's blue, which means it's correct. And actually, number of the vector is 23. Or here in reference manual 23. And we can actually take a look in the declaration that all of these vectors have been set up over there. This is the H file where you can find them. And let's enable the interrupt requests. Basically, I can copy this. Okay. Okay, the next step is to define our interrupt handler. It's actually very simple. You will just copy it, make a function out of it, delete this n, write handler, and now, what do we want to do when we press the button? Well, the interrupt routine should be as short as possible. There shouldn't be any delays, any complicated functions and algorithms. So to make a point, I will just, for example, switch a value of a variable from 0 to 1. So let's define the variables we will use. Example. Let's call it button. Make it equal to 0. And I will make another one, which we will use later. Okay, but when we press the button, basically the variable button will be equals 1. Okay, and this is very important. We need to somehow tell the MCU that the interrupt is done and you must go back to your main loop. To do this, we need to write 1 to the pending register. Or here's pending register 2, here, pending register. And here you can see that selected trigger request occurred when you write 1. This bit is set when the selected edge event arrives on the external interrupt line. This bit is cleared by writing a 1 to a bit. So basically when you press the button, this bit will set itself to 1, which means that the selected trigger request occurred. But it will occur repeatedly until you will clear it again. And to clear it, you must write 1 to it. Otherwise, you would get stuck inside an interrupt loop. Register. EXTI. Pending register 5. Like this. Okay. Now we have to write the function which will toggle the LED. can actually define it right over here. Let's name it like this. Actually not, let's make it a void. Let's keep it easy to understand. If button is equal to 1, do if LED is equal to 0, which is the default state where the LED is off, GPIO C BSRR, we already know what it is. It's set 8 because my LED is on pin 8, pin 9, and that's basically it for this half. Now LED plus plus out of the if statement, and now if LED is bigger than 1, GPIO C BRR bit reset register not 5, 8 and 9. So we are resetting the pin, and LED equal to 0. Escape the if statement, and button is equal to 0. So to explain the function, you press the button variable gets to 1. Inside a while loop, I will copy it inside. We will get inside LED toggle function, and we will see that the button is equal to 1. So we will get inside LED is equal to 0. We will set the LED. LEDs will be on. The LED variable will increase, but it is not bigger than 1. It will, from 0, it will increase to 1, but it will not go inside this statement. Button will be equal to 0, and again we will remain in empty while loop until we will press the button again. We press the button, we will skip this statement, LED will increase, and now this statement is true. LED is bigger than 1. So we will reset the diodes. Simple. Let's save. Let's build. And I will upload the code and I will show you the results. Thank you for your attention and see you next time.